3, we're going to multiply them together. 2 times 3 is 6.
No.
And it becomes cis of, and we can add the angles together. We're going to use the first rule. We've got pi on 4 plus pi on 2, and we'll write that in simplest form. 6 cis of 3 pi on 4. Okay? So they collect together. Now on to B. Now we have cis to the power of 3 theta. Now this rule is not expressed explicitly, but it's one that we can derive here. Have a look at this trick. Cis to the power of 3 means cis theta times cis theta times cis theta. That's what it means at the top there, doesn't it? So let's just focus on the top for now. And we know if we have cis theta times cis phi, we can add them together. So what that means, this is going to become, is it's going to be 2 cis of theta plus theta plus theta. Okay, we can combine it by adding them all together. I'm doing this in quite an elongated fashion, but that's okay. So that's going to be 2 cis of 3 theta at the top. Okay, so when we see a power, we can change it to be the number at the front. So we can, if you want, you can add that as a fourth rule, or my suspicion is you derive it in the exercise. Okay, then we want to collect these two. All right, so we're going to do the top power, or the top angle, take away the bottom angle. So what that's going to become, 2 cis of 3 theta take negative theta, gives us 2 cis of 4 theta. Okay, over the page, we've got the complex number z equals r cis theta. What way is that? Cool. Okay, so over the page we've got z equals r cis theta, and it wants us to find the conjugate of z, negative z, and the negative conjugate of z in polar form. Now I've written the answer up here and I'm going to provide my justification for it. First, let's visualize it, okay? Here's the Argand plane. This is going to be the complex number z, and the conjugate of z has the same real component, but it becomes the negative imaginary component, doesn't it? So if we have z is a plus bi, then the conjugate is going to be a take bi. It's just a reflection in the real axes. And so that means it has the same modulus, but the angle is minus theta. So that's how I'm getting that. All right. If we think about what is minus z, okay, it's going to be z, but in the opposite direction. Okay, so if we think about it in terms of the Argand plane, this angle is theta, and so then this angle is going to be theta. And so the argument of this complex number is this one here, okay, which is going to be pi take away theta. Why have I written that as theta take pi? Theta take away pi. We're describing it like that. Theta take away pi takes us to there. It's 180 degrees away. And then minus the conjugate of z. Well, if this is the conjugate of z, then this is going to be the negative conjugate of z, isn't it? It's in the opposite direction. And similarly, if this whole angle is pi, then the argument of this one's going to be pi take away theta. So that's how I'm getting that one. Then in part C, describe the translations. All right, well, we can see between z and the conjugate of z, it's a reflection in, that should be the imaginary axis. It's in the real axis, I mean. A reflection in the real axis. Okay, it's reflected about there. From z to negative z, okay, we're rotating it pi about the origin. Doesn't matter whether we go clockwise or anti-clockwise. Reflection in the imaginary axis. In imaginary axes, isn't it? Because it's just a reflection like that. Let me have a think about this one, but for now let's just call it a reflection in the imaginary axis. Okay.